All right, let's take a look at number 1. We are going to start by write 3 even degree functions with a negative leading coefficient and sketch the graphs. What do the graphs have in common? Well, I'm only going to draw 2 graphs. The one over here on the left is going to be, let's do f of x equals x squared, just a basic parabola, and f of x equals x to the 4th. But it said we have to have a negative coefficient. So I'll make this one negative and make this one negative. So we know an x squared is going to give us a parabola, so it's going to look something like this. And x to the 4th is going to have the same basic shape. It's actually a little flatter here. Not the best graph in the world, but it'll do. So what do the graphs have in common? Well, so as we look over here, we see that as we go to negative infinity, our graph's going down. As we go to positive infinity, our graph's going down. So if we were to use our notation, we would say something like that. Choose a different color. So as I go to negative infinity, my function's going down. As I go to positive infinity, my function's going down. And both of these graphs have the same, or they should have this in common. If I had x to the 6th, same thing. They have the same end behavior. Now if I make the functions positive, how does this affect the end behavior? Okay. So just flip the graphs across the x-axis. So our end behavior would be like this. As x goes to negative infinity, it goes to infinity. As x goes to positive infinity, it goes to positive infinity. And both of them have that in common. For a, odd degree, so again I'm only going to draw 2. So draw an odd degree function with a positive. So we could use f of x, x cubed, so just a basic cubic. And let's do f of x equals x to the 5th. So it's going to look like this, a little bit flatter there. And so what I want to look at is, look at the end behavior. As this one goes to negative infinity, it's going down. As it goes to positive infinity, our function goes up to positive infinity. Same thing here. So if I were to make the functions negative, it would just be the opposite. So think about it, if I made a negative, it would look something like that. And so as x goes to negative infinity, my graph is going up. As x goes to positive infinity, my graph is going down. Alright, so as we look at the next example, I'm going to change the problem, so we're going to ignore this one. And we're going to have x cubed minus 3x squared minus x plus 3. We want to look on the graph at this function. So the first thing that I ask for is it increasing or decreasing? And so increasing or decreasing is determined by the leading coefficient. So since the leading coefficient is positive, our graph is going to go up. So it's increasing. Next we're going to look at the number of turns. And the number of turns is determined by the degree. So Since it's 3, we take 3 minus 1 gives us 2. So at most we're going to have 2 turns. Now we're going to look at the y-intercept. And the y-intercept is determined by the constant at the end. And that's a 3, so we're going to be able to graph that. So our y-intercept is 3. This is the first point that we can actually put on our graph. Let's change color. Alright, now identify the number of real zeros. So we're going to look at our function, and since it has 4 terms, we're going to try grouping. And so as we look at x cubed minus 3x squared, what do they have in common? And so we notice that they both have an x squared, and so this becomes x minus 3. Now we look at the next 2 terms, negative x and positive 3. That looks a lot like this, except the signs are opposite. So what we can do is we can take out a negative 1, and that'll change both of our signs, so we get x minus 3. And so now, remember the important part when you group is that this and this are identical, and that's what we have, so we can continue. And so now we get x squared minus 1 and x minus 3. And so we know one of our zeros is going to be 3. But now this, we look at it and say, can we factor more? And so you should recognize that as being difference of squares, so x plus 1, x minus 1. And so our function is completely factored to this. And so now look at this, what makes this 0? So we have a negative 1, and we also have a positive 1. And so we have 3 zeros. So now we can graph those 3 zeros. Let's use red. Alright, so we have 3, negative 1, and a positive 1. So remember, our graph is going up, so over here our graph will be going up. And between the zeros, it'll make its turn. Now, unfortunately, with this pen, it's not the easiest thing to graph with, so we'll do the best we can. Let's do, I'm actually going to start down here, make my turn. I don't have enough information to decide where it actually turns at. So I don't know what the minimum or the actual maximum is, so it's just generic sketch, but it has a little bit more detail with the zeros and the y-intercept. And so now we can look at our end behavior. So as x goes to infinity, what's our function doing? What's our polynomial doing? So as x goes to infinity, our graph is going up. So that means it's going to positive infinity. As x goes to negative infinity, what's our function doing? What's our polynomial doing? So as we go to the left, our graph is going down. So we would say negative infinity. If you want to use the other notation, as our graph goes to the left, it goes down. As our graph goes to the right, it goes up. Alright, let's look at our next graphing problem. Same thing. We're going to start by looking at it and say, is it increasing or decreasing? Since this is a positive leading coefficient, we know that it is going up, so it's increasing. Now let's look at the number of turns. And so the number of turns is determined by the highest degree. And so it's 4 minus 1. And so that means at most we're going to have 3 turns. Let's look at the y-intercept. The y-intercept, the constant at the end, that negative 18. So we have negative 18. And so now over here for our graph, I can't put negative 18 on this unless I count by a different number, so I'm actually going to count by 2's. So then down here will be negative 18. And now let's see if we can identify the real zeros. And so we have 2x to the fourth minus 16x squared minus 18 equals 0. This time I am going to divide, take out the GCF, so I'm just going to divide everything by 2. And that gives me x to the fourth minus 8x squared minus 9 equals 0. And since it's a trinomial, we're going to try to just factor it. And so now look at the first term. And so right now x times x is x squared, and I need an x to the fourth. So if we do x squared times x squared, that'll give us the x to the fourth. Now we look at the negative 9. So we know we're going to have one positive and one negative. So what numbers are going to multiply to 9 but add to 8? And that's going to be 9 and 1. And since my middle term is negative, I know that the negative is going to go with the 9. So I can't do anything here. But over here, this is difference of squares, so this becomes x plus 3, x minus 3 equals 0. This is still x squared plus 1. And so the question says identify the number of real zeros. If I take this and make this 0 and I solve it, I'm going to get x squared equals negative 1, and I square root both sides, I get x equals plus or minus 1i. And so it's not a real 0. I won't be able to graph that over here. These two I'll be able to solve, and so x here would be negative 3 and positive 3. Now, even though I counted by 2's here, I'm going to count by 1's on the x-axis, so I'm going to graph those here. So we have 3, negative 3. And so think about what a degree 4 function is going to look like. As we started, remember, degree 4 is going to go up. As we go to negative infinity, it's going to go up as we go to positive infinity. So it's going to do something like that. If you want, you could go onto the Desmos.com and graph it and just to see what it really looks like. But you know, it looks something like that. Alright, so for number 3, create a function that matches the transformation. Remember that anything vertical is intuitive. When we write the function, it's going to look like what it does. So I'm just going to start by a generic f of x. And if I do a translation down, well, down you think negative, so just take a function minus 5. When I stretch by a factor of 2, it's just my function times 2. And the same thing, vertical compression would just be a third of my function. So now let's actually make a function instead of saying f of x. So I could just say f of x equals x squared minus 5. F of x is equal to 2 times x cubed. F of x equals 1/3 of x to the 4th. Now, anything that's horizontal is counterintuitive. So if I just start with f, remember, anything counterintuitive inside the parentheses. So left you think negative, but it's opposite of what you think. And so we actually write x plus 3. Now if a vertical stretch was a factor of 2, we put a 2. Well, horizontal stretch, it's counterintuitive because it's inside the parentheses, so it's not by a it's a factor of 8, but we write it as a fraction. And so now if a stretch looks like this, a compression is going to look like this. And so now if we actually write functions, so let's say our function is going to be x plus 3 squared. Here f of x is going to equal 1/8 x to the third, and f of x equals 3x, let's do to the fifth. Alright, and the last ones we're going to look at are the reflections. Okay, so when we go across the x-axis, it's just take the negative of the entire function. So if it's f of x equals negative x squared, and so reflection across the y is when the negative's on the inside, and so that would look like something like that. You might also want to go back and watch the videos on the Google Classroom about the transformations. Alright, let's take a look at number 4, adding and subtracting. So we have this polynomial minus the second polynomial, and whenever we subtract, it's basically we're going to change all the signs, or you can think of it as we distribute the negative into each term inside the parentheses. So I'm just going to rewrite the first. And now change all the signs. Minus 5x cubed minus 2x plus 9. So now we're going to combine our like terms. X cubed with another x cubed. So 3 minus 5 gives us negative 2x cubed. Now we're going to look for x squared. And I only have the 1, so let's just rewrite it. Minus 5x squared. Now we'll look for an x. There's only that one. So minus 2x, nothing to combine it with. And now we'll finish it with our constant. And so we get 1 plus 9 gives us positive 10. Number 5, now we're just adding. So when there's a plus sign, we don't have to worry about anything. We can go and combine our like terms. Again, you're going to want to put it in standard form. And so we have x to the fourth. It's our only one, so it's just x to the fourth. Now I'm looking for an x cubed. I don't have one. So now I'm going to go to x squared. So now I have a minus 3x squared plus a negative 2x squared, which gives me a minus 5x squared. Now I'm looking for an x. And I have one here, minus 5x. And now I'm going to look for my constants. So I have 5 and a negative 7, which is going to give me a minus 2. Alright, so now when we multiply, you have two ways you could do this. You could just distribute, or you could set up the box method and multiply. So x squared minus 5, 4x squared plus 8. Either way you do it, you're going to end up with the same answer. So x squared times 4x squared, I'll write it down here, 4x to the 4th, and then an x squared times 8 gives me a positive 8x squared. So now I gotta go negative 5 times 4x squared gives me minus 20x squared, and a negative 5 times positive 8 gives me a negative 40. And now I just combine my like terms. My only two terms are the x squareds. So my final answer is 4x to the 4th. 8 minus 20 gives me minus 12x squared minus 40. And you'll see if you do the box method, 4x squared times x squared gives me 4x to the 4th. Now 4 times negative 5 gives me the minus 20x squared. X squared times 8 gives me the 8x squared. And 4x squared times, 8 times minus 5 gives me negative 40. And the same thing, you combine your like terms. For these, happens to be on the diagonal, and that gives us the exact same answer, 4x to the 4th minus 12x squared minus 40. The good thing about the box method is that it forces you to fill in the 4 boxes so you don't forget any terms. For number 7, again, you could distribute this, but I'm going to do this one with the box method. Okay, so it doesn't matter which one you put on top. So x to the 4th. Let's make that really look like a 4. Okay, x to the 4th minus x squared. Make sure you include the signs. Positive 5. Here we have x cubed plus a 3x and the minus 1. And so now we're going to fill each box by multiplying the two terms. So x cubed times x to the 4th gives us x to the 7th. We're just adding the exponents. X cubed times a minus x squared gives us a negative x to the 5th. And then x cubed times 5 gives us 5x cubed. Now 3x times x to the 4th, 3x to the 5th. Remember, x has an exponent of 1, so 1 and 4 makes 5. 3 times negative is going to give us a negative 3, and then the x times x squared gives us x cubed. 3 times 5 gives us a positive 15, and with 1x. And negative 1 times x to the 4th gives us a negative x to the 4th. A negative times a negative gives us a positive x squared. And the negative 1 times positive 5 gives us a negative 5. So now here, again, we're looking for our like terms. So starting up here on the left, I have an x to the 7th. So x to the 7th. Now I don't have an x to the 6th, so I just work my way down. Now I have a negative x to the 5th. And so I'm going to combine this and this and see if I have any other x to the 5ths, which I don't. So 3 minus 1 gives me 2x to the 5th, positive 2x to the 5th. Now let's look for an x to the 4th, which I have just this one. So minus x to the 4th. Now my x to the 3rd. I have one here and one here. So 5 minus 3 is going to give me 2x cubed. And then everything else is just singleton, so just positive x squared plus 15x minus 5. Alright, so we start with number 8. Write the first 6 rows of Pascal's triangle. So we're going to start with a 1. And then our next row is 1, 1. And then our third row is going to be 1, 2, 1. Our next row, 1, 3, 3, 1. The outside edge is always 1. Now we get 1, 4, 6, 4, 1. And so now you might ask yourself, where are these numbers coming from? Well, if you look, the two numbers right above, 1 and 2 make 3. 1 and 2 make 3. 1 and 3 makes 4. 3 and 3, 6. 3 and 1, 4. And so we just keep repeating this pattern. So we start with a 1, 5, 10, 10, 5, 1. So we get 1, 6, 15, 20, 15, 6, 1. And so now I like to draw these lines. And this isn't our first row, this is our 0 row. And then 1, 2, 3, 4, 5, 6. And so these are the coefficients I would use for with a 6th degree. And so we'll look at number 9 and see how we use this row here to expand that binomial. Alright, so we're going to use these coefficients. 1, 5, 10, 10, 5, 1. And we're going to start making our table. And then just go and put open parentheses in each column. And now the first term, that 3x, you're going to write in each set of parentheses. And now we're going to start with our exponent. 5, 4, 3, 2, 1, none. So now I'm going to start simplifying on the right hand side. Anything to the power of 0 is 1, so we simplified that. 3x to the power of 1 is just 3x, so we've simplified that. 3x squared gives us 9x squared. 3x cubed gives us 27x cubed. 3x to the fourth is going to give us 81 x to the fourth, and 3x to the fifth is going to give us a 243 x to the fifth. So now we simplified everything we need to with the x's. Now draw a line and put another set of parentheses in this row. And now the second term, the y, the negative y, we are going to put in all these parentheses. And it's very important that when you do this, you include the negative. Alright, now we do our exponents. It goes in the reverse order. So 0, 1, 2, 3, 4, 5. And now start simplifying on the left side first. So anything to the power of 0 is just 1. So we've taken care of that. And so now this is the important part. Negative y to the power of 1 is negative y. Negative y, take care of that. Negative y squared now gives us a positive y squared. Negative y cubed, negative y to the third. Negative y to the fourth, positive y to the fourth. Negative y to the fifth, negative y to the fifth. And so now we're going to take this and put all our answers together. So you're going to take this times this times this. That'll be your first term. So 1 times 243x to the fifth times 1 gives us 243x to the fifth. Alright, now let's look at our second term. 5 times 81x to the fourth times a negative y. And so we're going to have a negative 405 x to the fourth y. Next term, 10 times 27x cubed times a y squared, and it's going to give us 270 x to the third y squared. Next term, 10 times 9x squared times negative y cubed, and it's going to give us a negative 90 x squared y cubed. Next term, 5 times 3x times y to the fourth, and I'm going to have to write off down here so I don't run off the screen. So it's going to be a positive 15x x y to the fourth. And finally our last one, 1 times 1 times negative y to the fifth gives us negative y to the fifth. So a couple things to look for when you do this with using Pascal's is, notice we have 5, and then 4 and 1 make 5, 3 and 2 make 5, 2 and 3 make 5, 1 and 4 make 5, and 5. So the exponents always add up to 5. The next thing I think you should be aware of is when we have this minus sign, we always have positive, negative, positive, negative, positive, negative. So the signs alternate. So let me know if you have any questions. Alright, so now we're going to look at number 10 and 11. We're going to evaluate the polynomial. So whenever we see the word evaluate, our final answer is going to be a number, a value. So we have our function, and we're going to evaluate it for negative 5. So what I like to do first is rewrite the expression with a bunch of empty parentheses. And so now when we replace x, we're going to replace it with negative 5. So wherever there was an x, negative 5 takes its place. Alright, so now we just start simplifying. Negative 5 cubed gives us negative 125. And now negative 5 squared gives us a positive 25. Now a positive 5 times a negative 5, minus 25, minus 7. And so I need to simplify the negative 2 times 25. And so now we just combine they're all negative, so you can just add them all up. And so you end up with negative 207. And since we started in function notation, let's finish in function notation. F of negative 5 gives us negative 207. So if my input's negative 5, my output is negative 207. Let's do the same thing over here now. So we have our function that we're going to evaluate for negative 1. Open parentheses. So our x is going to be replaced. Alright, so since x is negative 1, inside the parentheses we just put negative 1, and now we simplify. So negative 1 to the fourth is just going to give us a positive 1. Negative 1 cubed is going to give us a negative 1. And so now negative 2 times negative 1, positive 2. And now we just simplify. Gives us 4. So when I evaluate my function for negative 1, my output is positive 4. Alright, let's look at number 12, division. Now a couple things to notice is, first off, it just says divide. It doesn't say use long division, doesn't say use synthetic division, so you do the one that you're most comfortable with. So I'm going to go ahead and do synthetic division for number 12. A couple things that I'm going to look for is my exponents. It goes x cubed, squared, 1, and then none. And so I have all my degrees. So I'm not missing any, so I'm just going to write the coefficients. 2, 5, negative 23, and 10. And so now the number that's going to go here is what makes this equal 0. And so it's not negative 2, it's the opposite, it's positive 2. Kind of goes back to what we were talking about earlier for the graphing. If it's inside the parentheses, it's counterintuitive. It's opposite of what you think. Alright, so we bring down, and now we multiply. 2 times 2 gives us 4. 5 plus 4 is 9. Now we go 2 times 9 is 18. Negative 23 plus 18 gives us negative 5. And negative 5 times 2 is negative 10. And 10 minus 10 is 0. So this 0 is our remainder. And so what that basically means is that x minus 2 is a factor of that. Not quite what the question was asking. And so now as we go to write our answer, the next most common mistake I see is students will write 2x to the third. And that's not correct, because when we're dividing that, we actually go one less than our highest exponent, so it's going to be squared, plus 9x minus 5. And now we don't actually write this for this problem because it turned out to be plus our remainder, which is 0, over our divisor of x minus 2. So had I had a remainder, I would have put it above, on top, over my divisor of x minus 2. But that's not needed. This is my answer. Alright, let's look at number 13. I'm going to do synthetic division on this one also. And again, notice, I want to start by looking at my exponents. 3, oh, I'm missing 2. So since I'm missing 2, I'm going to rewrite this saying x cubed plus 0x squared minus 2x plus 1. So now when I go to do my synthetic division, 1, 0, negative 2, 1. And over here, remember what makes this thing equal 0? 3. Bring down. And now multiply. 3 times 1 is 3. 3 times 3 is 9. Negative 2 plus 9 is 7. 7 times 3 is 21. And 1 plus 21 is 22. So this is my remainder. So now I have to write it. So my highest degree is x cubed. So now this becomes 1 x squared plus 3x plus 7, and it's a positive, so it's going to be plus 22 over our divisor, which was x minus 3. Rewrite that 22. Alright, let's look at 14, 15, 16, and 17, all concerning factoring. So as we look at number 14, the first thing you should notice is we have a cube, we have difference, so we should automatically think difference of cubes. This happens to be one of my favorites. So first, can you rewrite these as cubes? Well, this could become 2x cubed, and the 27 can become 3 cubed. So since we're able to rewrite it like that, we and should write our formula. So it's a minus b, a squared plus ab plus b squared. And since we've already broken it down, we can just go ahead and let this is a, this is b, and just replace everything. And so this is going to become a is 2x, b is 3, so 2x minus 3. And for the video I'm going to show you guys, I'm just going to do step by step. So a is 2x, so this is going to be 2x squared plus ab, and so a is 2x, b is 3, and then plus b squared. And now I just simplify. So this gives me 2x minus 3. 2x squared is 4x squared. 2x times 3 gives me a positive 6x. And 3 squared gives me a positive 9. So a couple things if you want to just check to see if you got it right. Take the first term, 2x multiplied by the first term, 4x squared, that should equal 8x cubed, and it does. Take the last term, negative 3 times positive 9, that should equal negative 27, and it does. So hopefully, more than likely, we factored that correctly. Alright, number 15, as we look for factoring, you could start with the GCF, and so the GCF we have here is a 2, so let's take a 2 out of everything, and so we get 2x cubed plus 2x squared minus 9x minus 18. And so since we have 4 terms, we're going to try factoring by grouping. So cut it in half. And look, what do x cubed and 2x squared have in common? And so I can take an x squared out, and I'm left with x plus 2. And so now since these are both positive and these are both negative, I want to see if I can write it so that my binomial here will be positive. So I'm going to take a negative out, and so what do 9 and 18 have in common? So I can take a negative 9 out, and so that turns that into a positive x and a positive 2. And then don't forget we have this 2 on the outside. Alright, so since these, the x plus 2's are the same, I can rewrite it. X squared minus 9, x plus 2, bring the 2 down. And so now be careful, you're not done. You always rinse and repeat, you always go back to the start. Can something be factored? And so you're looking at this x squared minus 9, and hopefully you recognize that's difference of squares. So this becomes x plus 3, x minus 3, and x plus 2. So one of the most common mistakes students make is they don't check their work. So if I go x times x times x, I get x cubed, but something's wrong because it should equal 2x cubed. And that's because most of the time students will forget to bring that 2 down. So now 2 times x times x times x gives me that 2x cubed. And you can do the same thing for the last term. 2 times 3 is 6, times negative 3 is negative 18, times 2 is negative 36. So that looks good. Alright, over here we have x cubed plus 125, so can we write this as cubes. That's good. And then does something cubed give us 125? The answer is yes, 5. 5 times 5 is 25, and 25 times 5 is 125. And so now we should write our formula. A plus B, and then A squared minus AB plus B squared. And so this is going to be our A, this is going to be our B, and so this becomes x plus 5 x squared, and A is x, the B is 5, this is a step you could probably do in your head, but I'm just writing it out for the video. So we get x plus 5 x squared minus 5x plus 25. Do your quick check. X times x squared gives us x cubed. 5 times a positive 25 gives us a positive 125. So that looks good. Alright, so now on to 17. Start with your GCF. What do 4 and 32 have in common? So you can take out a 4. And now look at the x's. So they both have an x. So you can take out the lowest degree. So let's take out the x squared. And so when I factor this out, I'm left with x cubed. 32 divided by 4 gives me 8. I took the x squared out, and so now I just have x cubed minus 8. So now we have another difference of cubes. So I'm going to rewrite my formula again. And so this is just x cubed. This is just 2 cubed. So x is my A, 2 is my B. And so this is going to become x minus 2. And so a squared is just going to be x squared. AB is just x times 2, so we'll just go ahead and write 2x. And then b squared is just 2 times 2, which is 4. And so now we feel all happy inside. We go to check our answer. Take the first times the first. X times x squared gives us x cubed, which doesn't line up to 4x to the 5th. And the reason is because when we started this, we had this 4x squared, and then we saw the x cubed minus 8, and we went over here and did our difference of cubes. So we can't forget about that 4x squared. That's still a factor, so we're going to rewrite everything now. 4x squared times x minus 2 times x squared plus 2x plus 4. Now do your check. 4x squared times x is 4x cubed. 4x cubed times x squared gives us 4x to the 5th. Now the last. 4x squared times negative 2 is negative 8x squared. Negative 8x squared times the last 4 gives us negative 32x squared. Now that's not a complete check, but it's just a quick check to see if you're right. If you finish early, then you could actually come back and multiply everything out. Alright, so we're going to do number 18, and notice it says use the rational root theorem. Since it says that, probably means you can't factor this thing by grouping. So if you notice, you could take an x squared out, and that would leave you with 3x plus 2. The only thing you could take out here would be a 1 or a -1, and so the inside of the parentheses wouldn't work. So we do definitely need to do our rational root theorem. And so this is going to be P, this is going to be Q, and so we're going to take all the factors of P over all the factors of Q. And so P is nice and easy. It's just plus or minus 1, plus or minus 2. Q is plus or minus 1 or plus or minus 3. And so now we're going to write all our possible factors. So first thing we're going to look at is 1 over 1. And then we'll look at the 2 over 1. And so we have factors of plus or minus 1 or plus or minus 2. Now we look at 1 over 3 or 2 over 3. So plus or minus 1/3 and plus or minus 2/3. So now we have 2, 4, 6, 8 possible factors using our rational root theorem, and so now we just start doing our synthetic division. So our coefficients are 3, 2, -7, 2, and the first one I'm going to test, I'm going to start with 1 and just work my way through the list. I forgot to mention at the beginning of the video is that I changed the question to make it a little bit more manageable. So if you didn't catch that right off, the question's been changed. So bring the 3 down. And so now 1 times 3 is 3. 2 and 3 makes 5. 5 times 1 is 5. -7 plus 5 is -2. -2 times 1 is -2. And now 2 minus 2 gives us 0. So the first one I tried, I got a 0. That's what I want. So that means that 1 is going to be a root. So this is going to factor to x minus 1. Remember, 1 minus 1 gives us that 0, the root. And then this would be a 3x squared plus 5x minus 2. And so now you need to factor this. So now you write the factors. Do the a times c, so we get the numbers are going to multiply to -6, but add to 5. So since it's a -6, you might think 2 and 3 work, but since this is negative, that wouldn't work because one of them would have to be negative, and then it wouldn't add to 5. So it means we're going to have 6 and -1. And so now what you can do is take the coefficient, the leading coefficient, and write it underneath your answers, and then reduce this. So this becomes 2 over 1. You can't reduce a 1/3. And so now we take the 2 over 1, and we're going to write our factors. And so here, this 1 is our coefficient in front of the x, plus 2. This 3 is the leading coefficient here for this factor, so I get 3x minus 1. And then we have the x minus 1. And remember, we're trying to find the roots, the zeros. And so just make it equal 0, so we're going to have x equals 1. And this is just x plus 2, so we also have a -2. And then 3x minus 1. If you can't do that in your head, just come off to the side and just write 3x minus 1 equals 0. add 1 to both sides, and we get 3x equals 1, divide by 3, and we 1/3. And just real quick, you can come up here and check. Oh, we had 1, we had -2, 1/3, all part of our rational root possibility, so it looks good. Alright, let's take a look at number 19. For the given polynomial, test each of the possible roots, decide which one is a root. So our polynomial is x to the 4th minus 12x squared plus 27. And so the easiest way to test if this is root is to use synthetic division. You could substitute 9 in, and if it equals 0, then it's a root, but I'd rather do synthetic division. And so before we do synthetic division, we want to see, do I have, does it go x to the 4th, x to the 3rd? And so you see it's missing x to the 3rd, and so I'm just going to write it as 0 x cubed minus 12x squared plus 0x plus 27. This way, when I go to do synthetic division, I use my coefficients 1, 0, -12, 0, 27. And now we're going to test 9. And so you bring the 1 down, and now multiply it 1 times 9. 9 times 9 is 81. So we're going to get 69. 69 times 9, some number that I don't know off the top of my head. 621. 621 times 9, really big number, and I don't really care about it because I want a 0, and the only way that's going to be a 0 have that been a -27. So I know that 9 is not a root. Now, if you wanted to, like I was saying, you could just take 9 and substitute it in. And I haven't done this yet, so I'm going to have to use my calculator. But you're going to see it's going to be a really big number. 9 to the 4th is 6,561. 9 squared is 81. 81 times 12 is 972 plus 27. So now if I do 65, 61 minus 972 plus 27, I get 5,616, definitely not a 0. And so I now know that this would have been 5,616 had I just used my calculator to start with. So 9 is definitely not a root. Now before you just say, oh well, -3 is a root, you never know. Don't know until you try it. So you gotta have the work to prove your answer. So we can use the same coefficients over here. 1, 0, -12, 0, 27. And take that -3, bring the 1 down, so 1 times -3, -3 times -3 is positive 9, which gives us another -3, -3 times -3 is 9, and now you can see that 9 times -3 gives us -27, and so we get 0, which is what we want. So that means that -3 is a root. So if you just wanted to take the -3 just for fun and substitute it into your function, this out. So 3 to the 4th is 81, and it'll be positive. Negative 3 squared is 9. 9 times 12 is 108. And that would be negative 108. This would have turned into a positive, positive times negative, and then plus 27. And so you can see that 81 and 27 make positive 108. 108 minus 108 equals 0. Just showing that another way to get the same answer. That show that that is a root. So here's my answer. Negative 3 is a root. Alright, let's take a look at number 20. We're going to solve by finding all of the roots. One of the key words here is you see the word all. So we're not just looking for the real roots, any root we want. So we could have imaginary. Let's see what happens. Alright, so I have x cubed minus 5x squared plus 4 equals 0. And so you might look at this and say, oh great, it's a trinomial. I'm going to factor it like this. And say, okay, well what's going to give me the x to the third? So I might try x squared and an x. Okay, what gives me the positive 4? Oh, minus 4 minus 1. I feel good, everything's going to work. X squared times x is x cubed, negative 4 times negative 1 is positive 4. It must work. Well, you remember you do have to check the middle. So here, this would give me x cubed. Here, this would give me minus x squared. Everything looks good. The problem happens here. This negative 4 times that x only gives me a minus 4x. So it's not, I'm missing a square there. So I couldn't combine those. So unfortunately, that method is not going to work. So let's delete that. Not all that. Let's try to delete this. Alright, good enough. Alright, so we're going to have to try something else. Doesn't have a GCF, so the easiest thing to do next is to do our P and Q's. So this is our P, and this 1 in front will be our Q. So all the factors of 4 are plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1, and so that means my factors are plus or minus 1, plus or minus 2, and plus or minus 4. So I'm going to check this, start checking these possible factors using synthetic division. So this is x cubed minus 5x squared, and then make sure you include that 0x plus 4, and so my coefficients are 1, negative 5, 0, and 4. And so now I'm going to check. Let's just go ahead and start with a positive 1. So we bring the 1 down. 1 times 1 gives us negative 4. Negative 4 times 1 gives us negative 4. Negative 4 times 1 gives us negative 4. So we get 0. So that means 1 is a root. So now we're going to go ahead and just rewrite this in factored form. So x, so 1 is a root, so I want to plug 1 in. When I plug 1 in, I need a minus 1, so 1 minus 1 gives me 0. And now we're going to write this. So this was an x cubed, so this is going to become an x squared. So x squared minus 4x, a minus 4. And so this is done. Now I'm going to look at that and say, can I factor that? So you might start doing something like this. x. We're looking good. X times x is x squared. Now to get a negative 4, I could have negative 4, positive 1, but these would add together to give negative 3. I could do a negative 2, positive 2, but that would equal 0. So once again, I'm stuck with something that's not gonna be able to factor it. So we will try something else. So since this is x squared minus 4x, minus 4 equals 0. Since it's an x squared, I got a nice leading coefficient of 1. It's even. I'm actually just going to go ahead and complete the square on this. If you don't want to complete the square, you could use the quadratic formula, your choice. So I get x squared minus 4x, leave a blank, equals 4. And so now what I'm going to do is I'm going to look at this middle term, this b, and I'm going to take half of b, so a negative 4 divided by 2, and then I'm going to square it. So a negative 4 divided by 2 is negative 2, negative 2 squared is positive 4. So I'm going to add 4 to both sides. And the whole reason we do this is so that I can write as a binomial squared. So just take half of this there. And the whole reason we do that is because now I can square root. And when I square root, the square cancels out the square. The square root cancels out the square. And now I'm left with x minus 2 equals plus or minus the square root of 8. Now the square root of 8 can be broken down to 4 times 2. So I'll give myself a little more space. So the square root of 4 is 2. This 2 stays on the inside. And now I add 2 to both sides. And we get x equals 2 plus or minus 2 rad 2. So my solutions, or my roots, are x equals 1, and then from what we did over here, 2 plus or minus 2 rad 2. So we learned that if this is a 3, we should have 3 solutions. 1, 2, 3. So we have found all our roots. Alright, let's look at our last one, number 21. Write the simplest polynomial function given with the given roots. So, since these are our roots, they are solutions. X equals 2, x equals negative 3, and x equals 4. So now as I'm unsolving this, I would minus 2 to both sides, and this would give me x minus 2. Here I would add 3 to both sides, and this gives me x plus 3 minus 4, and this gives me x minus 4. And so if you can look at just the numbers 2, negative 3, 4, and go straight to this step, that is great. So now we need to simplify this, and so now let's pick 2 to multiply, and I'm going to work with these 2 first. So if you want to use the box method, you can. If you want to distribute, you can. Doesn't really matter to me. Let's see. Alright, so let's do x plus 3 here, x minus 4 here, and now let's fill in the boxes. X times x is x squared, plus 3x, minus 4x, and a negative 4 times 3 is a negative 12. And so we are going to have these like terms will combine. And so now this is going to become x minus 2, and then x squared, and then the negative 4 plus 3 gives us negative 1x minus 12. And so now I need to multiply the binomial times the trinomial. Okay, so we're going to have x squared minus x minus 12. Oh, I did that, and then x minus 2. I think I'm going to give it a erase just, yeah. So we can ignore that bottom row. I don't know what I was thinking. And so now let's multiply. So we get x cubed. X times negative x gives us negative x squared. X times negative 12 gives us negative 12x. And now x squared times a negative 2, negative 2x squared. A negative 2 times a negative x gives us a positive 2x. And then a negative 2 times a negative 12 gives us a positive 24. And so I'm going to combine my x squareds together. And I'll combine my x's together. And so now let's write our function. So we have x cubed, and then a negative 2 and negative 1 gives us negative 3x squared. 2 minus 12 gives us negative 10x, and then 24. So this function has the given roots 2, negative 3, and 4. So now let's do the same thing on this side. Now the whole reason I showed you guys this step is because now when I deal with the fraction, it's just a little bit easier to work with. And I know that this one's going to be x plus 2 and x plus 4, because this negative 2, when I put it in, negative 2 plus 2 gives us a 0. But this one is, sometimes tricky. So if I multiply both sides by 2, I get 2x equals 1. Now if I minus 1 from both sides, I get 2x minus 1. And so there's my other factor. Alright, since these are already up here, let's go ahead and multiply. So since I did the box over here, I'm going to just distribute. So x squared plus 4x. Let's change the color. 2 times x. And 2 times 4. And so now that's going to become x squared plus 6x plus 8. And let's distribute. Again, I showed you guys the box method over here, so let's do distribution here. And so 2x times x squared gives us 2x cubed. 2x times 6 gives us 12x squared. 2x times 8 gives us 16x. And so now negative 1 times x squared. So when you write your answer, line up your x squared, so you get negative x squared. Negative 1 times 6 gives us negative 6x. And negative 1 times 8 gives us negative 8. Now let's write our function. F of x equals 2x cubed, 12 minus 1 gives us 11x squared, 16 minus 6 gives us 10x, and then the minus 8. And so I would look at this and see if I happen to have a GCF, I would divide by it. Since I don't, I'll just leave it like that.